So to finish where I left off, we have this idea of where the x-intercept is. There's no y-intercept. And now we're going to graph this, and we need to just have a few additional points. But again, the vertical asymptote is going to be at the y-axis. So the y-axis is going to act like a line that the graph's not going to touch. The horizontal asymptote, or a line that's going to follow, is y equals 2. So let's just pick a few points. Let's pick 1. If I pick 1, if I plug in 1, I'm going to get 2 minus 1 over 1, which is just 1. If I plug in 2, I get 4 minus 1, or 3, over 2, which is 3/2. So what you're going to start to see is it's going to start to curve up like this. And then this direction is going to start to curve down. And then this acts as an asymptote, or a barrier that it can't cross. Now we need to try on the other side of the barrier. So let's try when x is a -1. What happens? Well, I get -2 minus 1. That's a -3 over a -1. That is a +3. So hopefully you can see that this is going to start to go this way, and then in the long run it's going to go like this, again following this imaginary line y equals 2. So it's going to follow that line as we keep going. So again, the same idea is going to happen every single time, and what I'm just going to keep having you represent is just understanding a couple of things. And what I just want you to be aware of, because I certainly know you're capable of plotting additional points. In the video, I'm going to talk about everything that's important for this graph, and then I might just plot 1 or 2 points, and then I'm going to have you look at the graphs. So after this, I'm not going to have a graph for each individual picture. I'm just going to talk to you about specifically what they look like. Okay, so this will be the last one where I actually go into detail for a full graph. So when we look at this, the first thing we're going to look at is the y-intercept. Okay, that's where x is equal to 0. Now if I plug 0 in, I'm going to get 0 in the numerator, but I won't get 0 in the denominator. But I have 0 in the numerator, so that's automatically going to cancel out there. Now if I try and figure out what the x-intercept is, that's where y is equal to 0. And the only way where y is equal to 0 is if this was equal to 0. Now if I multiplied this to the other side, what you're going to see is 2 things. One, you're going to see that we get x squared minus x minus 2 all cancel out, so we get 0 equals x. We multiply this all to the other side, and this already was 0, so we multiply that all out, we get 0 equals x. Well, we already got that. We already got that this point is the x-intercept, so we don't need to write it again. So it's both. Now I need to figure out just exactly where the asymptotes are. And hopefully you can see that based on this, we have a degree 1 over a degree 2. So in terms of horizontal asymptotes, the line y equals 0 is going to be one of them, because the degree in the numerator is smaller. Vertical is a little bit different because of the fact that we have a quadratic in the denominator. So I have to look at this and say, well, how am I going to deal with this equaling 0? It's factorable. I can factor this into two different things. So what we have here is we have two different asymptotes. So if I check both of these, I'm going to get an asymptote at 2 and an asymptote at -1. So we have some interesting things going on with this. I have two vertical asymptotes, one horizontal, and one intercept. So from a graphing standpoint, what this should look like, and some of these pen marks may disappear because I haven't figured out how to deal with that with this program yet. So we have the fact that it's going to follow the x-axis. At the line x equals 2, there is a vertical asymptote. At the line x equals -1, there is a vertical asymptote. Let's see, they kind of disappear. So we have a problem here. We know that this graph has an x-intercept at the origin. So what I would recommend you do is I would plot a point like 1, and you would get 1 over -2, and you'd get something in this range, and then you'll see that it goes something like this. If you plot points in between the two asymptotes, so you should plot in between the asymptotes. And then once you have that, maybe plot on the other side of the x-intercept and find that it goes that way. After you do that, plot on the other side as well, because in between these two asymptotes, it's not going to follow the horizontal one at all. It won't do that. Horizontal ones tend to follow as you get very large or very small. If you're just looking at what is happening between these two values, it's not going to do that. It's only going to happen as you get infinitely or very large or very small. So what we need to do is we need to look at this from a grand perspective. So if I picked 3, I would get 3 over what appears to be 3 over 4. So my guess is that this is going to look something like that. And if I plot on the other side, my guess is it's going to look something like this. But my suggestion is that you should plot on all sides of any asymptotes to get an idea of what the shape looks like on any sides of any asymptote, being vertical ones. Okay, now if you want an actual nice picture of this, then I would go to the book to look at it nice and clean like. So, just very quickly looking at this graph, I'm just going to talk about the main things, and then I'll have you sketch the other important things. We're talking about the x-intercepts, the y-intercepts, and the asymptotes, and then you can on your own sketch the important extra points on other sides of the asymptotes. So we have this function. It's degree 2 over degree 2, so the line is going to have the horizontal asymptote is going to be affected by the leading coefficients. So the x-intercept and the y-intercept. The y-intercept is when x is equal to 0. So if I let every x be 0 in this, I'm going to be left with negative 9 over negative 3, so I'm left with 0 over 3. So there's my y-intercept. For my x-intercept, what you're going to start to see is it happens when the numerator is equal to 0. So where is the numerator 0? So where is this 0? Well, if you solve this, you can solve that completing the square using square roots. You're going to get either plus or minus 3. So I have two different x-intercepts this time. So there's my x-intercepts, vertical asymptotes, it's where the denominator is equal to 0. That's factorable. If you factor this, it's going to be x minus 3, x plus 1. So we have two vertical asymptotes at x equals 3 and x equals negative 1. Horizontal, it's a leading coefficient over a leading coefficient. It's at the line y equals 1. And again, the same type of thing is going to happen for each one of these. And the checkpoints are very similar. The graphs, again, very similar for all of these. And in the examples, I'll go through them. I'll talk about where all of these key points are, and I'll make sure that you just are aware of where to plot key points. But in the last video, I'll talk about this idea of a slant asymptote, and I'll talk about the application problem real quick.